Okay, so let's take more solvings in our logarithmic function. Remember, we're still on solving using a logarithmic function. That's finding derivative of logarithmic functions. Okay, so let's take this one. If we have our y equal to what? Ln x exponential raised power minus x. Now, remember I told you about solving things like this. I told you that whenever you have two functions multiplying each other, then our ln, according to our simple rules in solving logarithmic functions, we know that ln x multiplying y will give us what? Ln x plus ln y, right? So I can apply this here, and then that will give us what? We have this as what? Ln x, which is the first one, plus what? Ln exponential negative x. So what is the, now we can now solve for the derivative of all of them. So we can answer for the dy dx of it. So what's dy dx of this particular? Remember, it's going to be the derivative of the x over the function of x. So that will just be equal to what? 1 over x in this case. And then plus for this particular one to also be what? The derivative of exponential minus x. Remember, if you take f of x, if you try to derive exponential minus x, what do you get? This minus, that's minus x comes over here and becomes minus exponential minus x. We've done this a lot of time in our in the exponential function zone. So that'll be minus exponential minus x over what? The func, that's the f of x, which is exponential minus x. So we can notice here that this can cancel out this, and what do we have? We have just 1 over x plus what? Sorry, this is going to be minus 1, because this cancel out, this will give us 1 remaining. So 1 over x minus 1, and that's our final answer. You can find the LCM and put it in compact form, which should be what? 1 minus x over x. Now that's one way. So let's take one more question again. What if we're given this to solve? If we're given y is equal to x squared ln x. Now, notice something. This is a function multiplying another function, right? So we can apply what rule? We can apply the product rule. In solving this particular one, we can apply the product rule. So now, sometimes they might not give it to you like this. Sometimes it might be given to you in this way. Ln x squared. But remember I told you that according to one of the laws in logarithm, we know that whenever we have ln x raised power y, it is equal to what? Y multiplying ln x, right? So that also we can apply. If the question was given to us in this form, we can just say this x squared multiplies the ln x. It helps you work very easy to solve. So now, solving this particular question, what do we do? Remember our product rule, our dy dx for product rule tells us that what? That v du dx plus u dv dx, right? So the next thing we have to do is to bring out our v and our u and find the derivative of the v and u. So what's our u? Our u will be equal to what? X squared. And our v will be equal to what? Ln x. So what's our du dx? Du dx will be equal to what? 2x. And our dv dx will be equal to what? 1 over x. Remember, the derivative of ln x is 1 over x. So therefore, we know that our dy dx will be equal to what? We have this as v du. So what's our v? We have our v to be ln x. So it's ln x du. Du is what? 2x. Plus our u is x squared. And then multiply by our dv. dv is what? 1 over x. So what's the final answer? 2x times ln x is 2x ln x plus, we know that this can cancel out this and we have just x remaining. So this is our final answer. Okay, so finally let's take one more question to cap it all up for ln solving. So I would like to split my screen. Now this one is going to be very interesting. We have y is equal to ln x squared over x plus 2 bracket x minus 3 and then close def. Okay, now in solving this one, remember I told you we can break them down to what? To the law of logarithm, which tells us that whenever you have ln x over y, it can be equal to what? Ln x minus ln y, right? So breaking it down here, we know that our y is equal to ln x squared minus, we can minus ln x plus 2 x minus 3. But also notice something here. In this particular case, we're also seeing a multiplication inside the ln, right? So we can also break this down again to be what? Plus, right? So it will be equal to ln x squared minus, we have here as ln x plus 2. Put this in a bracket so we won't confuse ourselves. Minus, that's plus right now because this is product, so we have plus ln x minus 3. So let's put this in brackets. So when our minus opens the brackets, we have ln x squared minus ln x plus 2 minus ln x minus 3. Okay, so now we can easily solve for it. So from here we can solve for the derivative. Now solving for the derivative, we know that we find the derivative of this particular one, derivative of this, derivative of this. So for this particular case, remember this particular ln x squared, I can easily solve it. I can just take my 2 over to this way, right? I can just take my 2 as 2 ln x just to simplify my working. I can solve it straight away this way, but if I want to simplify it, I can just take my 2 over here minus, here's ln still x plus 2 minus ln x minus 3. Remember why we did this? Because I showed you in this particular case where we have, look at it here, that if we have this thing that's an x to the power of a value, you can take the function that is raised to power and use it to multiply your ln function. So what we did here, our 2 came to the back and multiplied our ln function. Now let's proceed. Okay, I can take my screen over to the other side. So we have here as dy dx. Now we can now solve for each of them, for dy dx for each of them. So let me take each of them separately. So I'll solve them separately. So I can say my dy dx for, let's call this let's call 2 ln x as our first function. So let's solve for 2 ln x. So for 2 ln x, let's call it function 1. Then we have that dy dx for that. Dy dx for 2 ln x. What do we have? We have it as 2. What is the ln for this particular one? It will be, remember how do we find this particular case? We say that it will be what? Our 2 is multiplying this. Now it will be 2, our f of x, remember this is f prime of x over what? F of x. So what's our f prime of x? It is going to be giving us, so it will give us what? It will give us, for our f prime of x, we know this will be 2 multiplying. Now for ln x, we know it is just going to give us 1 over x actually, so here will just be 1 over what? X. So the answer will be what? 2 over what? X, right? You can also check it using ln x squared, because if you're having ln x squared, it's actually going to give you a very easy way of solving. So the derivative of x squared will give us what? 2x over, is like saying 2x over the function of x, which is just x squared, x squared. And then when you divide the x, cancel out x, you have just 2 over x. That's the final answer. So that's just it. Let's continue for the next one. So for the next one, we have minus ln, well, let's not put a minus first of all. Let me just solve without the minus. We have ln x plus 2. Let's call this equation 2. And then we have that our dy dx for this case is what? Remember what I said again, you find the derivative of your function over what? The f of x. So what's our derivative of x plus 2? To give us what? Just 1, because x will just give us 1, and then over we have x plus 2. So that's the answer. So this is the answer to this particular one. Then the next one is for ln x minus 3. We have again that our dy dx is equal to our f prime of x over our f of x, which will give us what? Still 1 over what? X minus 3. Now in essence, therefore, we can then set our y, our dy dx, for that's the main dy dx right now, bringing in all these functions, will be equal to what? It will be equal to 2 over x minus, because we have a minus here, we have a minus in this case, minus 1 over x plus 2 and minus 1 over x minus 3. And we can stop here. So this is the final answer. We can take more questions if you want to, but we'll stop here, then I'll give you the rest as an assignment.